This is the Test Doctor video for cumulative assessment number 4. This one is all about equations. And you should have ready to go your Test Doctor video correction sheet. Remember how this works. You will fix the original problem that you missed, and then I will give you a new problem to do at the end of the end after we've worked it out, okay? So I'm going to start with number 1. So if you missed number 1, you write number 1 here. You're going to fix it with me, and then you will do the new problem after, okay? So the first one says 3 increased by a number x is 9. Now, if you remember the steps for writing expressions or equations, first you're going to circle the numbers. So 3, a number x, and 9, and then you're going to underline the operation words. Increased and is, we underline because it's going to be my equal sign. Step number 3 is just to write it out. So 3 increased, that's an addition operation word. So added to a number x is my equal sign, and it equals 9. So that, well, my last step is to check for flip-flop words, and increased is not a flip-flop word, so I leave it just like this. Okay? If you missed number 1, now you're going to redo this new problem, which is 80 is 28 more than a number h. So follow the same exact steps. You will circle the numbers, underline operation words, write it, and then check for flip-flop phrases. Okay? All right, moving on to question number 2. So question number 2 says write the word sentences in equation. So it's exactly the same as number 1. Step number 1 is to circle all of your numbers. So the product of 17 and a number y is 153. So I have 17, a number y, and 153. Step number 2 is to underline the operation words. So I will underline product and is. Product means to multiply. So when I write this, I'm going to do 17 multiplied by y is my equal sign, and then the 153. Remember, this 17 times y can be written right next to each other. If you have a coefficient and a variable, they are multiplying each other. So you do not need a dot, you do not need parentheses. However, if you did put that, it's technically not incorrect. So, but you don't need it, so don't write it if you don't need it. Okay, if you missed that, I would like you to redo this one. The product of 19 and a number w is 76. So you're going to do the same things. Circle the numbers, underline the operation words, write it, check for flip-flop phrases. Okay, moving on to number 3. Okay, number 3 says, tell whether the given value is a solution of the equation. So this is checking solutions. You're going to box whatever they said the answer was. Your equation is 4w equals 44. W equals 10 is the solution they give you, so we're going to plug it in. So 4 times 10 equals 44 once we plug it in, and now we solve it. What's 4 times 10? That is 40. Is 40 equal to 24? It is not, so this is not a solution. Okay? So if you missed number 3, then I would like you to tell whether this is a solution of the equation. So we have 6s equals 30, and tell me if s equals 4 is a solution to this equation. So this is your new problem. Okay. Number 4 is the same type of question. Tell whether the given value is a solution of the equation. So you have y divided by 6 equals 6. Remember, when you have a fraction, it's just a division problem. And the solution they're giving you is y equals 24. So I box that solution. Now I'm going to go ahead and plug it in. 24 divided by 6 equals 6. Now I go ahead and solve it. 24 divided by 6 is actually 4, right? Is 4 equal to 6? No, they're not. So this one is also no, not a solution. Okay, if you missed number 4, try this new problem. I have y divided by 4 equals 3, and you said y equals 12. Check and see if 12 is the correct solution for that problem. Okay, moving on to question number 5. So number 5 is another check the solution. Tell whether the given value is a solution of the equation. W equals 5, box it. We're going to go ahead and plug it in. So you have 2.5 multiplied by 5 equals 12.5. Okay, so now the next step is to go ahead and solve that. I'm going to write it out here. 2.5 times 5, what's 5 times 5? That's 25. And 2 times 5 is 10, plus 2 is 12. And then how many numbers do I have behind the decimal? I only have that one, so my answer should also have 1 behind. So my answer is 12.5. So look at that, I have 12.5 on both sides of the equal sign. So this is, yes, a solution of the equation. Okay, now if you missed number 5, I would like you to try this new problem. So I'm going to write number 5 new. It's going to be 2.2x equals 11, and the solution is x equals 5. Check and see if 5 is true and if that works in there. All right, moving on to question number 6 right here. So question number 6 says solve the equation, check your solution. So this is when we start using our railroad tracks, okay? So we are looking to see what S equals. So first I am going to rewrite it so it's a little bigger. S minus 3 equals 19. Step number 1, draw railroad tracks. Step number 2, circle the variable and anything that's attached with it. Step number 3 is to do the inverse operation. Remember that the goal is to get S all by itself on one side of the equal sign. It's got to be alone. So in order to do that, I have to do the inverse or opposite operation of anything that's with it. So I have this subtract 3 or negative 3 next to this S. So to get rid of it, I'm going to do the opposite. Now the inverse or opposite operation of subtraction is addition. So whatever I do to one side, I have to do to the other. That's step 4. I've got to do it on this side and this side of the railroad tracks. Okay? So step number 4 is to go ahead and solve it. When I have negative 3 plus 3, that becomes 0. Okay, which is why I do it, so I can get the S alone. And 19 plus 3 equals 22. So I get S equals 22. So I got it right there. Okay, and I box my solution, and then that should remind you that the last step is to check it. So now I plug it back into the original. 22 minus 3, does that equal 19? Yes, it does. So I know that 22 is indeed the correct answer. Okay, if you missed question 6, I would like you to solve this equation. X minus 7 equals 11. Go ahead and solve this. This is number 6, new. Okay, solve this. And then I'm going to move on to question number 7, which is another solve the equation. Okay, so 14 plus y equals 20. Okay, so remember my first step is to draw the railroad tracks. Second step is to circle the variable and anything attached. Third step is to do the inverse operation, so y can be alone. This is positive 14 right? If there's no sign, then it's positive. The opposite of positive is negative 14, so the inverse operation is going to be subtraction. Step 4, whatever I do to one side, I must do to the other. And then step 5 is go ahead and solve it. So when I have 14 minus 14, that's going to be 0. Okay, so now y is alone. Bring down the equal sign just down the tracks. And 20 minus 14 equals 6. So I got 6, and step number 6 is to check. So I plug it back into this original. I have 14 plus 6 equals 20. And 14 plus 6 is indeed 20. So I know that 6 is the correct answer. Okay, if you missed number 7, then I would like you to solve this equation. So this is number 7, new. Go ahead and do q plus 6 equals 21. Go ahead and solve this equation if you missed number 7. Okay, question number 8. Now you're going to write the word sentence as an equation and solve it. So this is a 2-step problem. First we're writing it and then we're solving it. So just like we did a couple of problems ago, first you're going to circle the numbers. A number W decreased by 10 is 3. Now I'm going to underline my operation words. I know that decreased is subtraction and is my equal sign. So now I write it. A number W decreased by 10 is 3. Okay, so that's what you should have had for the first box. Okay, for the answer, now I would switch over and I would draw railroad tracks. Step number 1. Step number 2, circle my variable. Step number 3, do the opposite. The opposite of subtracting 10 or negative 10 is adding 10. Step number 4, whatever you do to one side, you must do to the other. Negative 10 plus 10 is 0, and 3 plus 10 is 13. So W equals 13. And then I'm going to go ahead and check it by putting it back in. Is 13 minus 10 3? Yes, it is. So we know that that is the correct solution. So you should have both of those pieces, that equation and the answer to the equation. So if you missed that, then the new problem for question number 8 is this. You're going to write and solve. So a number D decreased by 12 is 4. Okay, so same thing. You're going to first write it as an equation, and then second, you're going to solve it. Okay, number 9 is the same type of problem. Oh, just kidding. You're not. This number 9 is just solving. Solving and then checking. Okay, so you're going to go ahead and do your railroad tracks and solve. So 5a equals 60. Okay, so first you're going to draw a railroad track. Second, you're going to circle the variable and anything attached. Now this time we do have a number attached. And remember, when they're attached like this, they are multiplying each other. So step number 3, do the opposite operation, the inverse. The opposite of multiplying is division. Whatever I do to one side, I must do to the other. And when I have 5 divided by 5, that's going to become 1. And we don't need to write the 1 in front of a variable because we know if it's not there that there's just 1a. So now a is by itself, which is our goal, and 60 divided by 5 equals 12. So we got a equals 12. Last step is to check and make sure that that's true. Is 5 times 12 60? Yes, it is. So we know we got that one correct. Okay. All right. New problem. If you missed number 9, your new problem is 8a equals 32. Go ahead and solve this problem. This is new for number 9. Okay, now moving on to question number 10. This is another solve the equation and check your solution. So remember, the first step is to draw railroad tracks. Second step is to circle the variable and anything attached. Now this number that's attached is dividing 2. So I'm going to do the opposite of division, which is multiplication. I'm going to multiply by 2. Whatever I do to one side, I must do to the other. Okay, and when you have a 2 over a 2, just like cross-simplifying, these become 1s. And so we have m by itself again, which is our goal. M equals 40 times 2, which is 80. And that is what I get for my answer. Now I'm going to check it. Is 80 divided by 2 40? Yes, it is. So 80 is correct. Okay, if you missed number 10, here is your new problem. I would like you to do x divided by 2 equals 8. This is your new one. All right, question number 11. You are going to write the word sentence as an equation and then solve. So this says the product of 3 and a number h is 18. So first step is to circle all of the numbers, 3 and a number h and 18. Second step, underline the operation words. Product, I don't know, is multiplication, the answer to a multiplication problem. And is going to be my equal sign. Now I'm going to go ahead and write it. So the product, 3 multiplied by h equals 18. So that's my answer. And now I'm going to go ahead and I'm going to solve it. So write it over here. First step, railroad tracks. Second step, circle the variable and anything attached. I know that these are multiplying because it told me when I wrote the equation, and because when they're next to each other, that means multiply. So the opposite of multiplying is dividing. That's the inverse. Then I go ahead and do that to the other side. I cross simplify, make that a 1 right there, and then I solve. H equals 18 divided by 3, which is 6. So I get h equals 6. Now I check, is 3 times 6 18? Yes, it is. So that is the correct answer. If you missed number 11, I would like you to do this one. The product of 2 and a number g is 24. Okay, so this is number 11 new. Go ahead and write it as an equation and then solve it. Okay, number 12. This is telling whether the ordered pair is a solution of the equation. So remember, when you have an ordered pair, the first number is always your x, and the second number is always your y. So now I'm going to plug those values right into the equation and substitute them. So where y is, I'm going to put the 16. And where x is, I'm going to put the 7. I always teach my students to do parentheses when they put these in so that they remember that this is multiplying each other and they don't forget. So I go ahead and solve it. What is 3 times 7? 21. And 21 minus 5 equals 16. So I got 16 equals 16. So yes, that ordered pair does work and it is a solution to that equation. So if you missed that one, I would like you to check and see whether this ordered pair is a solution to this equation. So your equation is y equals 5x plus 2, and see if the ordered pair 2 and 12 works in that equation. So this is number 12 new. Okay. All right, number 13, I believe, is a similar question. Yep, tell whether the ordered pair is a solution to the equation. So y equals 12x, and my ordered pair is 3 and 32. The first number is x, the second number is y. Okay, go ahead and plug them in. I plug the 32 in for y, and I plug the 3 in for x. Now I go ahead and solve. 12 times 3 is 36. Is 36 equal to 32? No, it's not, so my answer is no. All right, if you missed that problem, I am going to have you do this problem. Here's your equation. Y equals 2x minus 10. Oh, I can't give you that one because it's on your next one. How about y equals 3x minus 2, and your ordered pair is 1, 1. So this is number 13 new. Tell me if that ordered pair is a solution of the equation. Okay? All right, now, number 14, you tell which ordered pair is a solution. Okay, and it should give you the options 25, 40, as well as 7 and 3, I believe. Okay, so we're going to try 7 and 3 first. So this is x, this is y. Plug 3 in right here, and plug 7 in for x. So 2, what am I doing? 3 equals 2 times x, which is 7, minus 10. Okay, 2 times 7 is 14. And so 14 minus 10 actually equals 4. And so that is not the same. That is not going to be your solution. So hopefully this one works. It should. So I go ahead and plug that one in. So I plug in 40. That's going to equal 2 times 25 minus 10. What is 2 times 25? That's 50, right? And 50 minus 10 is 40. And there we go. 40 is the same as 40. So my ordered pair that works is the 25, 40 ordered pair. Okay. Now, if you missed that one, same type of problem, I would like you to tell me which ordered pair works for this equation. You have y equals 3x minus 5. Tell me if A, 410, is the solution, or if B, 2, 1, is the solution to that equation. All right, question number 15. Now we're starting into some of the review questions to see if you remember what we have learned in the past. So this one is asking you to use the distributive property to simplify the expression. So there are a couple ways that we did this one in my class. I'll go over both of them. The first way we learned is on the notes. That's with the box. Okay, so you draw a box and you cut it in half. And then on the side, you always write the number that's outside of the parentheses, and on top you write what's inside. So you write the 2x on top of one box and the 3y on top of the other with the sign right in the middle. Okay, and then you're going to share the 7 with both boxes because distribute means to share. And then you're going to bring the 2x down with this 7 and the 3y down with the second 7. Now you go ahead and multiply. So 7 times 2x is 14x, and 7 times 3y is 21y. Okay, and so that is going to be your answer. Now, in Mrs. T's class, we also accept it if you just do the arches. So 7 times 2x is 14x, and 7 times 3y is 21y. So that's just a little quicker way. But if you like the box, use the box. Okay? If you missed that problem, please do this one. Use the distributive property to do 5 times 3y minus 2. So use the distributive property to simplify this one, and this is number 15 new. Okay, number 16 is simplifying the expression by combining like terms. So this is when we first circle all of the terms that we have, quite a few on this example, and then we're going to separate them into families or groups. So on this, we have the x's, I can see, and there's a y, and we have numbers. So this time you actually have 3 different families or terms that go in different groups. So now I separate them. The 5x goes in the x column. The 3y goes in this one. 9 is a number. -3 is also a number. And yes, we always keep that. And you're going to say, well, isn't that a subtraction sign? And yes, it is. It's also a negative. They are the same thing. So you need to keep that sign with it. And then you also have a -x. Now, if you remember, anytime there is no coefficient, there's always an invisible 1 for your coefficient right there. Okay, so now we go ahead and combine those. 5 minus 1 is 4x. That 3y just stays right there. And then you have 9 minus 3, which is 6. So your 4x plus 3y plus 6 is the correct answer. Okay, if you missed that problem, go ahead and combine like terms on this one. This is new number 16. You're going to do 3x plus 7 plus 5x minus 2. So go ahead and simplify by combining like terms. Okay, next up, question number 17 is GCF and LCM of 40 and 60. Okay, so 40, we're going to break into 2 times 20, and then 20 into 2 times 10, and 10 into 2 times 5. Okay, so there's my prime factorization for 40. I'm going to go ahead and just draw my Venn diagram right now. So it's going to be 2 times 2 times 2 times 5. Okay, and then we have 60. We're going to do 60 is 2 times 30. I'm just going to stick with my 2's. 30 is 2 times 15, and 15 would be 3 times 5. So my prime factorization for 60 is 2 times 2 times 3 times 5. Okay, remember that every pair that you have goes in the middle. So I have a 2 and a 2 on that side, so 1 comes down. I have a 2 and another 2, so I bring another 1 down. And I also have a 5 and a 5, so I'm going to bring the 5 down. Okay, and anything that's in the middle is my GCF. So GCF equals 5 times 2, which is 10, and 10 times 2, which is 20. Okay, and your LCM is going to be whatever is on the top, M for multiple. So I bring down this leftover 2, and I bring down this leftover 3, and I'm going to multiply everything straight across. So 20 was inside. Now I'm going to do 20 times 3, which equals 60, and then 60 times 2, which equals 120. You also could have done 20 times 2, which is 40. 40 times 3 is 120. It doesn't matter what order you multiply, right? Commutative property. So that's your answer there. Okay, if you missed the GCF LCM number, I would like you, for your new problem, this is number 17 new, to find the GCF and LCM of, let's do 45 and 30. Okay, so if you missed that, go ahead and try this one. All right, question 18. Use GEMDIS to evaluate the expressions. So we're doing order of operations, okay? I'll write that down here. Okay, so we have 2 to the 3rd power minus 12 divided by 6 plus 8. So G is for grouping symbol. Inside my grouping symbol, I have 12 divided by 6. That equals 2, right? So I'm going to rewrite that. Okay. Now, E is for exponent, so I'm going to get rid of this 2 to the third power. Now 2 to the third power means 2 times 2 times 2. So 2 times 2 is 4, and 4 times 2 is 8. So this is going to be 8 minus 2 plus 8. I don't have any more multiplication and division, so I'm going to add and subtract from left to right. 8 minus 2 is 6, and 6 plus 8 is 14. So that is my correct answer. If you missed that one, please do this new problem. So this is new number 18. Evaluate this expression by using GEMDIS. So 2 to the fourth power minus 36 divided by 4 plus 7. Okay, so go ahead and use GEMDIS or order of operations to evaluate this or solve it. Okay, question 19. Our last one, the bonus question. Yes, you still need to do the bonus question. This is a two-step equation. So this means we're going to have to do a little bit more work. Okay, but the steps are still the same. First, I'm going to draw my railroad tracks. Then I'm going to circle my variable and anything attached. Okay? Now, instead of just getting rid of one thing, I actually have to get rid of two things. I have to get rid of this 4 and this 2 so that x can be alone. So I'm going to start with the things that are not attached first, okay? So I'm going to get rid of this minus 4 or negative 4 first. The opposite of negative 4 would be positive 4. Whatever I do to one side, I have to do to the other. This is going to become 0. And so now I'm left with x over 2 is equal to 4. Because 8 plus 4. My bad. 8 plus 4 is 12. Okay, now I keep going. I'm going to circle my variable again and everything that's attached. I have x divided by 2, and the opposite of division is multiplying by 2. Whatever I do to one side, I do to the other. This 2 over 2 cross simplifies to a 1, right? And then I'm going to have x equals to 12 times 2, which is 24. Okay, so that's what I got for my solution. Now I'm going to check it. 24 divided by 2 minus 4 should equal 8. Let's try it. 24 divided by 2 is 12, and 12 minus 4 equals 8. So this is indeed the correct answer. Okay, if you missed the bonus question, I do want you to try this one. Where do I have it? I might have to make one up for you. I am. Okay, so this is number 19 new. Solve this equation. Let's do t over 4 plus 6 equals, let me think about this for a second so I make sure it ends nice and neat. Let's do 18. Let me make sure that works. Yeah, that should be good. So go ahead and do this as your new problem. Okay, make sure you have completed this and that you have the original problem fixed and the new problem for every single question that you missed.